We have all questions now. There's no question numbers for this. All the questions we have to do. Chapter 6 of EC book, workbook. Chapter 8 is the number for electrical book. Chapter 6 and 8. So I just follow this workbook. EC book I'm following now. EC book का number order में I'm going. According to that, you can just take the question in your electrical book if you want. So I'll take the reference of EC book now to do these problems. So let us start doing one by one the problems. EC का book 1 hour में complete करते हैं concepts. So I hope you have been studied on them all the questions, so you can make easily these questions. So chapter number 6 I'm doing. Chapter number 6 in EC book I'm doing. EC book multi-stage amplifiers. First question. I think first question you know the answer for that. I think first question you can know the answer for that. Okay. Multi-stage amplifiers. I don't want to give any short notes because everything is in notes only. There is a short notes. Okay. Whatever the conclusions I have given, that is short notes. No need of requirement for multi-stages. Multi-stage topic is not that much important for me, so that's why I'm giving just direct attack on the problems now. This module I don't want to give any short notes, so you can start doing the problems. So first one you can do it directly. No short notes for this topic. This is Q1. This is Q2. And we have the load. This is your I naught. This is your input. So we know that GM of cascode will be equal to GM1 of the first transistor. This we have already studied in our special cases. GM1 will be the correct answer for it. GM1 will be the correct answer. Great. Second question, if you see clearly, question number 2. He has given capacitors, VCC, all these things, but he is asking the GM of the overall stage. It is just looking for me a cascode system. It is correctly if you observe. This is one MOSFET he has given. One MOSFET. Maybe he has taken PMOS. Okay. I think he has taken PMOS. He has taken PMOS diagram. You have some input. Just AC model I am writing. AC model. You have some resistor to ground. So if you see clearly, this model is just looking like a cascode because this is a common source and this is a common base. So please understand that cascode can be designed with a combination of transistors. Composite transistors we call. You can take MOSFET, you can take BJT. You can make composite wise. I think bottom one he has given is common source he has given. Bottom is a common source, top is a common base transistor. You know the concept that this current is IC. This current is IE current. This current is your ID current. So these are the currents flowing there. So GM is nothing but IC divided by VIN. GM is nothing but IC by VIN. The answer is this one, GM1. But in the question if you see correctly, GM1 of the MOSFET he has given is 2 milliamps per volt. But in the option it is not same 2 milliamps, means exact answer he is asking. If you want exact answer, IC can be represented as alpha times of IE you can write by VIN. IC is equal to alpha IE, exact way of doing problem. So alpha can be written as beta by 1 plus beta into IE can be written as ID by VIN. Drain current by VIN, which is nothing but beta by 1 plus beta into GM of FET. So you can see the accurate answer. Beta is given in the problem is 99. So 99 by 100 into 2 milliampere per volt. So like this, if you solve, you get the accurate answer. Okay. In the options he has not given accurate, so we are finding with the accurate called alpha technique. Alpha can be written as beta by 1 plus beta. So question number 2. Question number 2 is D is the correct answer. The answer is coming to be 1.98 milliampere per volt. So it is coming to be 1.98 milliampere per volt. So question number 3. This is a cascode system. Please try to understand. This is a cascode. This is a cascode problem. Question number 3 is talking about Darlington pair. It's talking about Darlington pair. In Darlington pair, he has given 3 parameters. One is voltage gain, how much, input impedance, how much, output impedance, how much. Voltage gain I have seen is 1, input impedance I have seen is high, output impedance we have seen is low. So these are the properties I have seen in common collector to common collector. Input impedance is very high, voltage gain is unity, output impedance is low, we are getting. So most of the students have given B answer, great. Question number 3 is B, great. So fourth question if you see, question number 4. Question number 4. An amplifier using BJT have 2 identical stages. That is N is equal to 2 stages as well. And the 2 stages are identical. These are 2 identical stages. And the lower cutoff frequency, FL has given as 64 Hz. For one stage, your FL is 64 Hz. And the lower cutoff frequency of overall amplifier is, I think you have to find out FLN of N formula. For identical stages, I have given already how to find out FLN of N and FH of N. The formula is for identical stages, FL by root over 2 power 1 by N minus 1. So straightforward formulas I'll apply and solve these questions. So this is my calculation. FL is given as 64 Hz and divided by root over 2 power 1 by 2 minus 1. So just solve this answer for 2 stages. I think it is coming to be 100 Hz is coming. 100 Hz. So the formula which we have to use is this formula. Option A is 100 Hz. Confirm thus, good answer, great. Both is also getting 100 Hz, good. Fifth question, you can see here also bandwidth question it is. Question number 5. Question number 5 we do here. Question number 5 he has given 2 different cutoff frequencies, higher cutoff frequencies. F1 is 5 MHz. F2 is 3.33 MHz. You consider this as FH1 for us, this as FH2. So whenever they have given two different frequencies, automatically it is non-identical stages. So we have some equivalent formula for this. Non-identical stages, your FH formula is 1 by root over 1 by F1 square plus 1 by F2 square. So this is the formula which I have been explained for you. So it's a non-identical stages, so two cutoff frequencies make it square root. So this answer will be 1 by root over 1 by 5 square plus 1 by 3.33 square. So actually this answer is not matching with any option. It's not matching any option. You are getting some 2.58 megahertz something. So it's not matching with your answer actually. It's coming some 2.58 or 2.75 something. But options are two answers they have given, which is lying between these two. One answer is 2 megahertz is also there. Another answer is 3.33 megahertz. So which answer is correct you can think? It is coming in the middle of 2 megahertz and 3.33. One must be the answer according to the concept. Can you see that this frequency is already individual stage frequency? He has given in the option individual frequency. So but we studied in the class the bandwidth always will be less than individual bandwidth. If your bandwidth is concerned with F2 is 3.33, same answer you are going 3.33. So a single stage and a multi-stage will not have the same bandwidth. It will get always less than the single stage. So I think this must be the wrong answer. This must be the correct answer. So with the principle we have to answer this question. So we should not take 3.33 because it's a single stage of bandwidth. So we have to go for multi-stage. Multi-stage bandwidth will be always greater than less than single stage bandwidth. That is a logical question. So question number 6 we'll see now. Fifth question is completed. Apita, it is not B option. C is the option here. It is not 3.33. It is 2 megahertz will be the answer because single stage bandwidth and multi-stage bandwidth will not be same. That I am telling you. Okay. 2 megahertz will be the correct answer for it. So next going to question number 6 in the class. Question number 6. An RC coupled amplifier has a voltage and band gain of 20. He said that it is having a band gain of 20. It is a mid band gain of 20 we have. And measured at a particular frequency shows the gain. This is your particular frequencies. One is FL and one is FH. Particular frequencies will get 14. So what is this 14 is? Just we have done here 20 by root 2, which is going to be 14. At this 14 we got a lower cutoff frequency and higher cutoff frequency. And he's asking you what will be the likely phase shift at this frequency. Generally the bandwidth, whatever the bandwidth we have, bandwidth will be considered as FH minus FL, but we are considering only FH. That means if we can find the phase angle here, the phase angle if you can find here, that will be the answer. So exactly at FH, you can investigate what is the phase angle for that. If you want to learn what is the phase angle, this response at higher frequencies, the response is low pass response. First notify that at higher frequencies it is a low pass he said, because higher frequencies the gain is attenuating, so it is called as low pass. At higher frequency if it is low pass, what is the voltage gain formula here is AV is equal to transfer function you can take. AV is equal to AM mid band gain divided by 1 plus J F by FH. So this is a low pass transfer function. A low pass transfer function. If you don't know, just make a low pass circuit. Already in somewhere I found the transfer function of low pass system somewhere in my frequency response plot. We got the 1 plus J F by F beta we got. F beta is the current gain bandwidth. FH is called voltage gain bandwidth. Same formula it is. Okay. So just you have to write this J term formula 1 plus J F by FH. If you want the phase angle at a higher per common emitter if you want, it will be phase angle at higher plus 180 degrees you have had, because it is already having 180 degrees phase shift. So just to find out the phase angle at higher is, it is 1 plus J F by FH. So tan inverse y by x you find out. With when it goes up it will be negative sign. So minus tan inverse F by FH plus 180 extra you have to add for common emitter amplifiers, because it's already created with 180 degrees. So 180 plus that phase. 70 thus at higher frequency. Why it is called low pass means simple logic. You can see here. Suppose if I write like this, you can see. This is the responses. If I cut this into two parts, you can see that this part, lower frequencies is passing, higher frequencies is not passing, so it is a low pass. That is at the higher side. If you come to lower side, lower frequencies are attenuating, higher frequencies, so it's a high pass. So this is the meaning actually, why you got band pass. If you cut the total frequency response into two parts, this side if you see, higher side the gains are attenuating, so it is not passing higher frequencies correctly, it's passing lower frequencies. So in that manner you have to understand it. So if I write here tan inverse, if the frequency becomes FH exactly, plus 180 degrees, exactly my frequency is your cutoff frequency, this will become minus tan inverse 1 plus 180. It will be minus 45 degrees plus 180. So it will be 135 degrees. So like this we got the calculation here. So whenever they ask you the phase angle, this is the way how to calculate. It is not minus 45, it should be minus 45 plus 180. Total will be 135 degrees will be the phase angle for this concept. So this completes the sixth question. Shavnidas, I hope you understood. This is a lower frequency it is sending, higher frequency it is attenuating. This side if you see, higher frequency is going, lower frequency is attenuating. So whenever you cascade a high pass with a low pass, we get band pass. Okay? High pass with low pass. Anupam Das, your frequency is exactly at this. You are asking me the phase angle. And the frequency you are applying is equal to the FH frequency. If these two are same at the time, what is the phase you are finding? Exactly you want at the time, what is the phase angle? Anupam Das. Okay? That's why F is equal to FH, we have to substitute. Question 6 is completed. Question 7 is a theory question. Question 7. Already in previous class I explained about this concept called impedance matching. Impedance matching. So why we use impedance matching? I told yesterday in somewhere, instrumentational amplifier topic I explained. An instrumentational amplifier, what is the last concept I told you is amplifier should connect to loudspeaker. Whenever loudspeaker you connect, the loudspeaker impedance is very small, such that my amplifier output impedance should be small. So buffer is better there, I said common collector. So impedance matching purpose is what? how the gain formula comes here. Everything is a doubt शबरीदास आपको पूरा डाउट्स होते हैं. इधर एक रेसिस्टर लेवल कर जाकर एक कैपेसिटर लेकर C को लेवल here input, this is output. जस्ट ये सर्किट लेकर आप ट्रांसफर फंक्शन निकालो यार. राइट, कितने बार लिखना है ट्रांसफर फंक्शंस. R into C का ट्रांसफर फंक्शन निकालते हैं. FH को 1/2 by RC लिखा मैं. Okay, FH is equal to 1/2 by RC. That is called FH. This we have been explained these topics in your frequency response analysis. So that is the reason directly I am writing the formula there. So if you have any doubt this transfer function how it came, you just apply this function. Transfer function apply करके देखो. Okay. So impedance matching purpose is to achieve maximum power transfer. It is to achieve maximum power transfer. Maximum power transfer. So for this reason we use impedance matching. If you want maximum power to deliver to the load, we use impedance matching technique. So the best impedance matching circuit in electronic society is common collectors or emitter followers are the best impedance matching circuits. And question 8, this question also, as a student you can tell the answer. As compared to the impedance of the signal source, the input impedance of a voltage amplifier should be, if you have a signal source here, like this, Vs, and if you have Rs here, this is your input impedance of your amplifier. It's asking you how to take the input impedance of an amplifier is asking. What is your answer for this? For 8th question, what should be the answer? I think yesterday I told you, no current should go here. Current should not go, voltage only should go. That means you want Vs here. Voltage should go means input impedance should be infinite is better. Means lot is better. This only we call it as a loading effect solutions. So one question is on loading effect is asking, one question is asking on the impedance matching. Okay? Small A, large A. Very high resistance is required such that the voltage source what you apply will go to the amplifier. Okay? He's not asking current to go, he's asking voltage to go. So 8th one should be the B is the answer for it. 9th question, question number 9. Is also a theory question. Question number 9. Non-linear distortion. Non-linear distortion in an amplifier is caused by, if you see clearly, he is telling non-linear distortions in an amplifier. So amplifier is basically created by a transistor, correct? Transistor itself is giving a non-linearity. How sir non-linearity means? If you see the formula here, IC is equal to IS into e power VB divided by VT. This is in DC analysis. This is in DC analysis. If you have AC analysis, your small IC current will be equal to IS into e power your V input divided by VT. This is AC analysis. So can you see that your output current is a relation of exponential of input. Your input signal is in the form of exponential. Because of that exponential, this form will become 1 plus x square by 2 factorial plus x cube by 3 factorial plus so on. Like this you are going to get a non-linear distortion. That means basically your device itself is a non-linear device. Because of your non-linear characteristics of your device, you are getting non-linear distortion in amplifiers. So what should be the answer for this is, your option A will be the correct answer. It is non-linear dynamic characteristics of your active device. Because of your active device is non-linear, so your device is getting non-linear. So it is a non-linear characteristics of active device. Because of this reason we are getting non-linear characteristics of active device. Because of that we are getting this harmonic, what you can say, non-linear distortions in your subject. So 9th one, A will be the correct way of answering the question. Now 10th question is related to a Darlington pair question. Try to solve this question by yourself. 10th question एक बार try करो. Question number 10. He has given a Darlington pair. This is Q1, this is Q2. This current is IB1. This current is IE1. This current will be equal to IB2. And this current will be IA2. This current will be IC2. He is asking you the overall HFE of the composite transistor. He is asking you HFE of common collector to common collector. It becomes IC2 by IB1 will be the current gain. The second transistor current divided by the first transistor input current. Okay, this is the calculation you have to do it. Some students will do mistake here. Let us see what is that mistake. Your IC2 divided by IB1 is the answer he is expecting. So IC2 can be represented as, can write it as beta times of IB2 divided by IB1 I have written. IC2 can be represented as beta times of IB2. Okay, beta times of IB2. But what is IB2 here is IE1. So beta times of IE1 by IB1. IB2 and IE1 are same. But what is IE1 here is, it is 1 plus beta times of IB1 divided by IB1. So I think your HFE of common collector to common collector is beta into 1 plus beta should be the answer. Beta into 1 plus beta. Beta is given in the problem is 100. 100 into 1 plus 100. So this must be the answer for it. Some students will get 10200 will come, one person will get 10100. Which is correct answer, you can check it. Bose has given 10200. This becomes 1 plus 101 is, will become 101 into 100. So I think your answer will come as 10100. So option C will be the correct answer. Okay? It's a very simple question. Composite filter, he is asking the beta well, composite circuit. 10100 is the answer for it. So with this 10 questions have been completed. 11th question is a normal basic question which is called harmonic distortion formula, how to write. Generally what is the definition of harmonic distortion? If you know it, this formula is easy. Question number 11 you can see. If you want a total harmonic distortion, it is equals to modulus of n stages of harmonics divided by d1. This is the formula actually. overall harmonics of n stages divided by your first fundamental, it is D1 here. So what is the magnitude of this is? You have to start with the A2. A2 is the second harmonic, square plus A3 square plus like that. An square will be there. This is a Dn in magnitude, total harmonics, divided by fundamental will be A1. So this is the way how to write the harmonic distortion formula. So Parthasarathi, a point दिमाग में रखो, he is talking about HFE. He is not asking 1 plus HFE. Okay? HFE, if you ask, the formula is IC by IB. If you ask 1 plus HFE, which is called gamma, gamma को हम लिख सकते हैं IE by IB. थोड़ा बहुत confuse होकर answer of 10200 में जाएगा. Okay? Beta formula is IC by IB. Please remember that. It is not IE by IB. If you ask gamma, then you can say IE by IB. That point will confuse you actually. Okay? I hope you understood it. So harmonic distortion formula will be this one, basic formula it is, which will be used in power amplifier topics. Yeah. It is IC by IB. Yeah, correct. So 11th one, B is the answer for it. This is 11th one. Harmonics always start from second harmonic. Okay? First harmonic we never have in our life. First will be always fundamental. That's why take the fundamental which is required. Distortion will be above, which is in magnitude. You have to write like this. Yeah, Parthasarathi. If they ask you current gain of Darlington pair, then you take IE by IB. But he's asking here HFE. Okay? Dn is called n stages per distortion. Okay? If you have n stages, you have overall n stages per distortion. That it should be in magnitude you want. So magnitude answer is root over a square plus b square like that. Nth distortions by divided by the first harmonic, first fundamental. If you make it, you will get the answer for that. This is the standard basic formula. Like this. For this not required. Only basic knowledge should be there for this formula. Next question number 12 if you see. 3 identical amplifiers have open circuit voltage of 50. So you can see the diagram for this. 3 stages he has taken. 2K. Next the gain is 50 into V1 will take. Output resistance is 500. You can see this is a voltage control voltage source. Open circuit voltage gain. Whenever they give voltage gain, this is the structure which I taught in the class. Okay? High impedance, low impedance. This is high, this is low. This is V2. Like this he connected 3 stages. This is 2K. 50 into V2. This is 500. Again we'll get some V3 output. We have 2K. 50 into V3. 500 ohms. This is your output as V4. So this is the meaning what he said. 3 identical stages are connected. Just an amplified model I have represented for voltage control voltage source. How to write the model? We studied in the first topic. We have written out first topic design in 3 models. All are 3 identical stages. Input impedance is 2K everywhere. Output impedance is 500 ohms. Gain is 50. He's asking you the overall gain of the amplifier. If you want overall gain, it should be V4 by V1. We have to solve. V4 by V1. It is V4 by V3. You can divide. V3 by V2. V2 by V1. 3 stages you can find separate answers. So the first answer if you solve here, V4 is nothing but here no current is passing here because the load is open here. He has not given any load there. So open circuit is set. So I equal to 0. So 50 times of V3. So V4 by V3 is equal to 50. This is the one gain I completed seeing the model. V4 by V3 is 50 we got. The second one, here we have the load because the next stage will become your load. So let us find out this answer. V3 is a voltage division rule. It is total 50 into V2 into 2K by 2.5K. Just apply the voltage division rule. So it becomes V3 by V2 becomes 40 is coming. This is the second point, second equation. And here also current is not 0. So here also similar answer will come. That is V2 is equal to 50 into V1 into 2K by 2.5K. So V2 by V1 is also 40 is coming. So you can see 3 answers. One is 50 is coming, one is 40 is coming, last one is 40. So these 3 stages find out the gain for it. The overall gain. The overall gain is 50 into 40 into 40. It is coming to be 80,000 will be the gain. You can see very high gain we got. Multi-stage gains are very high. So 5 force 20, 20 forces 80. 80,000 gain is coming for this. But in the question have you observed? Is asking in decibels because we are getting very high values in magnitude. If you want to compress the value, go for decibels. What is decibel is telling is AB in decibels. Simply make it 20 log of 80,000. So make it 20 log. The formula is 20 log. If you apply it will become decibels. In the coming class all the op-amp questions gain problems we do in decibel scale. Just a 20 log you applied. If you apply 20 log for that, this answer will come as 98 decibels. So in decibel scale the magnitude will become very small value. So 80,000 in magnitude we can also call it as in decibel scale 98 decibels we call. We call it as 98 decibels. So this completes your concept how to do it. So question number 12 is completed nicely. Question number 12. 13th question you can solve it. Try karo ek bar 13th one. Solve the 13th question. Meanwhile I'll take some water. Shavnikas, can you see your first topic? What I taught in our class? Basic types of amplifiers. 4 topics I taught for you. Again you're asking me, sir, how to write the diagram. A diagram take the feeling as voltage control voltage source. Anybody want? Input you have to represent Zi. Output you have to represent a voltage source. Any practical voltage source will have a series resistance called Z0. This is your first topic, which I taught in your notes. Voltage control voltage source. This is also voltage control voltage source. This is also voltage control voltage source. Just have written structures by seeing your data. Okay, in the exam, sir, you should have the talent. Okay? Whenever they give voltage gain, you have to draw like this. If they give current gain, suppose, you have to keep your current source in parallel to the resistance and you have to make a model and you have to solve the question. Okay? It's a voltage gain problem. Okay, Shavnikas, great. Wonderful. Good. So come to the last questions. We are very close to the problems completed today task. We'll go for a new chapter. Question 13, you can see. Question 13. If you see question 13, here he has given some RS we have a voltage source, and if you just connect to input resistance here, suppose this is your RIN, which is 700 ohms. This becomes your VIN. The next we have is gain is coming AV into VIN, which is having some R naught, and finally it is connected to a load. This is V naught. So in the question is asking what is V naught. V naught is nothing but what we can write V naught here. This is a voltage division rule you can apply. V naught is equal to AV into VIN into RL by RL plus R naught. You can solve like this. AV into VIN will become your voltage into that resistance by total resistance. But what is VIN come from this circuit is, it is Vs into, here also voltage division rule, RAN by RAN plus RS. So you can solve this problem with the AV into Vs into RAN by RAN plus RS into RL by RL plus R naught. It's a basic question actually. It's a basic amplifier question. Usually you can solve it. So AV I think in the problem he has given 20. Vs also given I think 10 millivolts. RS has given 600 ohms. Load is 1K. Everything is there in the problem. Just find out this answer. So please try to solve this question. So input resistance he has given 700 ohms. This R naught I think he has given 1 kilo. So let us finish this answer. How much will come V naught? Find out this answer. According to my data, it is coming 53.84 millivolts. You must get this much answer. If you apply this complete data in the problem, your answer should be 53.84 millivolts will come. That is your amplified output. Because VSC has got 10 millivolts actually, so it is getting amplified for 53.84 millivolts. So this is the answer. And what about the T1 question answer? T1. It's a Darlington pair input impedance. Darlington pair input impedance I have written as R by 1 plus 1 plus beta. He has got two betas, so you write 1 plus beta 1 into R by 2 plus 1 plus beta 1 into 1 plus beta 2 you write into RE. In the notes I already given the knowledge for you how to write input impedance for a Darlington pair. Here he has given R by 1, R by 2 same I think. So in this problem R by is same. Beta 1, beta 2 are different. That's why style of writing answer is like this. So T1 question, try to solve it. You will get this answer as ZIN will be R by is 1K plus 1 plus beta is 1 plus 50 into 1K plus 1 plus 50 into 1 plus beta 2 is 1 plus 100 into RE is 1K. So this is your ZIN in the problem. Yes, Anupam Das, good answer. 5.203 megaohms is the good answer. 5.203 megaohms. Exactly, accurate answer. All answers are very close to each other, so accurate answer you have done. It is 5.203 megaohms will be the accurate answer for this question. So 11th question is completed. Sorry, T1 question is completed. Only 2 more questions to finish these problems. He's asking T2 question. एक बार देखो T2. Two voltage amplifiers are connected. The approximate overall gain. We already done this type of question. T2 type of question we have done called voltage control voltage source diagram slicker. Find out condition. This problem I think I'm expecting you can do it. T2 you can do it. Yeah, Anupam Das in triple book we have seen one extra question is the rise time problem. That question I have been covered already in MOSFET. MOSFET somewhere we got the rise time question 0.35 by bandwidth I have given. So you just note on it. In the electrical book that fifth question is a rise time problem 0.35 by FH will be the answer for it. 0.35 by bandwidth. I think you will get around 0.7 microseconds. That question already we deal in MOSFET. Somewhere we got the question yesterday amplified question. Electrical book maybe repeat our question. So let us write the answer yourself you can write. It's not required to teach here. Otherwise at the end I will give that conclusion for you. So T2 question I'm expecting you can do it. T2 question is easier, you can do it. What is that? We have RAN. This is RAN. Next we will have a gain. Open loop gain. Open loop gain is at 10. And resistance here will be R0. Up to here you have voltage control voltage source. This is VIN. This is a V2 will take. After this again we have this RAN1. This is RAN2 you take. Next we have is another gain he has given in the problem is 5. 5 into this is VIN. This will be V2. Next we have a resistance here R01. This you take it as R02. R01 is 1K. R02 is 200 ohms. RAN2 is 5 kilo ohms. And RAN1 is 10 kilo ohms. Just write voltage control voltage source models. But in this question what he done is, he finally connected a load answer here. Load he connected as 1K. In the previous question I think load he has not connected. Here we have connected the load. Yeah, in triple rise time is 0.7 microsecond. Mukesh Kumar, correct answer. Great. So please complete this one. So if you want to solve this answer, again, it is output by input. It is V0 by V2, V2 by VI. So you can solve in two parts. This is one division rule you can apply. V0 is equal to 5 into V2 into 1K by 1K. This is 1K by 1.2K. This is the voltage division rule you can apply. So V0 by V2 you can calculate. It is 5 into 1 by 1.2. This is V0 by V2. And coming to the next one, V2 is equal to 10 VIN into 5K by 6K. 5 plus 1 is 6K. So V2 by VIN will be 10 into 5 by 6. So just these two answers you calculate and see the answer how much is coming for this question. एक बार ट्राई करो ये आंसर how much is coming. Overall answer ट्राई करो. 5 divided by 1.2. It's coming 4.16. This game. It's coming 4.16. 4.16 and 50 by 6. 8.33. So one gain is coming 4.16. Other gain is coming 8.33. So overall gain if you want. Overall gain. 4.16 into 8.33. 4.16 into 8.33 is 34.65. So this is how you can solve the question. Okay. So the last question we have finally 34.65 something is coming. Yeah, 34.65. The last question what is asking, try to understand it. The final question. T3 question, एक बार try करो. 3 identical RC coupled amplifiers he has given. The last question. T3 question. And T3 question, he has given some frequency plot like this. This is one frequency, this is one frequency. FL he has given frequency as 20 Hz. And FH he has given as 1 kHz. So he is asking you for 3 identical stages. If you want these answers, FLN of 3 stages. You know the formula I think, FL by under root of 2 power 1 by 3 minus 1. You just solve this lower cutoff frequency for 3 stages. And if you want this answer, FH of 3 stages will be equal to FH into under root of 2 power 1 by 3 minus 1. So please try to solve this too and see that what will be the boundaries of your response. They have given 4 graphs like this. You want to know this response graphs. I think some options will be wrong. Straightforward you can tell. Option A is wrong answer. Maybe option B is there. Option C is also wrong answer. How I'm telling option A is wrong answer means he has given 20 Hz again in your option. Habibi, आपका multi-stage bandwidth will be less than will get means this answer will come this side, this answer will come this side. So option A गलत है, option C भी गलत है. Option C he is given 1 kHz. तो दो answers नहीं होते. So option B, otherwise option D can happen. Option B or option D. One option he has given 2 kHz he has given. He's going out of this portion. So these questions actually don't use formulas, use common sense and logic. So option D also wrong answer because you cross it the FH. Actually your bandwidth will come like this. Your bandwidth will come like this. It will come inside. So according to the options if you see, I'm expecting this calculation will come as 40 Hz. This answer will come as 0.5 kHz. So without doing also we can tell this answer. Okay, this is observation, theory observation wise. A, C, D are wrong answers I can tell. So time waste will not be there. D also wrong answer. Yeah, D also wrong answer because your FH of N will come this side, not that side. Okay, so B will be the correct answer for it. So nicely we have been covered the workbook of chapter 8 of electrical and chapter 6 of your EC book. I'm expecting all the questions are clear. If any doubt you have, you can see in the recording video the solutions. In future it will be helpful for you. So anyway, I completed up to this concept. So today class, one important foundation topic is completed to enter into the op-amp designs. The next foundation topic is very, very crucial and very, very important. Okay, very crucial topic. It's called as differential amplifier study. If you understand this study only, tomorrow when I teach op-amps, it looks easier and better for you. Today maybe I have 2 hours exact time. So maybe today class I may take 4:30 to 5, around 5 o'clock and stop the class. So within 5 minutes I'm going to start the class. Just relax for 5 minutes. A new module is going to start now. Okay, just 5 minutes, 3, 5. I'm going to start the class. So just 5 minutes I'll relax. Within 5 minutes we are going to start a new module. 5 minutes. Why I said 5 minutes means we are stopping the video here, and again we are starting a new video called as that one. What I can say, differential amplifiers, a new module.